Okay, 8.3, all about integration by parts. Okay, so sometimes in math, when you want to try to integrate something, you can't use U substitution. If you use U substitution, you won't be able to cancel anything out, and you have a product. So this is more like, remember how we used to have a product rule? F times G prime is equal to F prime G plus G prime F when deriving. Here is the same exact thing, but for integration. So we have a different rule, and it's called integration by parts, IBP. It's more of like, kind of like the product rule, but for integration. So if you have an integral, okay, of two functions, f of x times u of x, but I'm going to call these different things. If you have an integral of u dv, okay, it's equal to uv minus integral of v du. Walid, what are you writing? What is this, bro? This looks like letters, right? But to use this, I'm going to have to use an example so that I can explain for you, okay? So the first thing is integral. I'm going to give you a very easy example of x cosine x, okay? Over here, we have two functions being multiplied by each other, right? So what rule do we have to use? We have to use this rule. Integral u dv equals uv minus integral v du. So when doing this, I need to have my table. When you figure out your table, everything becomes easy. So what are the two things I need to know? Is I need to choose my u and I need to choose my dv. So what's my u going to be equal to, and what's my dv going to be equal to? So I need to choose my u and I need to choose my dv. What else are we missing? What else do we have? So we're starting with u and dv, and we're ending with the dv becomes a v. So this dv becomes a v, and this u becomes a du. So as you can see here, we need our four variables that we need to fill in. When we figure out what these four are, then we can just plug them into our formula, right? Okay, so here is very easy steps. How do you solve any question with integration by parts? You write down your integral and you write down your table. U equals, then under it you say du equals. Then you say on the side dv equals, and then under it you say v equals. Okay, to go from u to du, what does that mean? It means you're deriving. Okay, and to go from dv to v, you're getting rid of the derivative. So what does that mean? You're integrating. So I want to start with a value in u, and I want to start with a value of dv, so that it's easy for me to derive and it's easy for me to integrate. Now, it really doesn't matter what you choose, whether you choose x here or whether you choose cosine x here. It doesn't matter. You're most probably going to get the same answer at the end. But one will take you 50 times longer than the other. So you need to be smart. So here's what I like to do. I like trying both variables here, x and cosine x. If I choose x here, what's the derivative of x? 1. As you can see here, we got rid of the x. Now here, if I choose cosine x as my dv, the integral of cosine x is sine x. So as you can see here, we got rid of our x term. And if we try integrating it, let's plug everything in. U times v, so u times v x sine x, minus integral v du, so sine x, du is times 1. Oh, let's just put in a dx here. Okay. Now, this is very easy to solve, so it's going to be x sine x minus, what integral of sine x? It's negative cosine x, right? So this is going to be obviously plus c. So this is going to become a plus. So the answer is x sine x plus cosine x plus c. So very simple. So the question you need to ask is, which one is easy? Which one is easier for me to derive, and which one is easier for me to integrate? Always, if you have a linear function like x or maybe 7x, throw that in to your u, because it's very easy for you to derive 7x. 7x just becomes what? 7. You know what I mean? Okay. So let's try and solve using our rule. So over here, using the rounded values, cosine 4 is negative 0.7 and sine 4 is negative 0.8. Integrate this. So let's integrate from 0 to 4. Let's forget about our bounds. We need to integrate 11x sine x dx. Now this is a good question, so it will definitely come. Okay. So over here, we're going to use our product rule. What is it? Integral u dv is equal to uv minus integral v du. So we need to start with our table. U and dv. We're starting with them. Then we write du under them, and we write v. So let's see. What am I going to choose as my u? What am I going to choose as my dv? Which one is easier for me here to derive, and which one's easier for me to integrate? The easiest thing to derive here is 11x or sine x. The easiest thing to derive is 11x, because 11x, خلاص, it's just going to give me 11. Okay? And dv here, if I put sine x, then v is going to be what? Negative cosine x. So let's plug everything in now. U is 11x, v is negative cosine x, minus integral v du, so negative cosine x, du is what? 11. And just throw the dx here. If it's written, you need to put this dx here. Okay? Okay, so it's very easy now. Let's just simplify this. 11x times negative cosine x is negative 11 cosine x. This minus, I'm going to make it a plus over here. So I'm integrating 11 cosine x. How do I integrate 11 cosine x? It's very easy. It's just going to be, take the 11 out, it's going to be 11. What's the integral of cosine x? Sine x. And obviously plus c. So we don't need the plus c because we have our bounds from 0 to 4. Okay, so let's just put from 0 to 4. Very easy. Let's now substitute. They said use, let's substitute. So it's going to be negative 11 cosine 4 plus 11 sine 4 minus, open brackets, negative 11 cosine 0 plus 11 sine 0. Very easy. 11 sine 0 is 0, so I'm just going to throw that away. Negative 11 cosine 0 is 1. So negative 11 times 1 is negative 11. And negative, you have this minus outside. So minus 11 will become plus 11. Okay, negative 11 cosine 4, that means minus 11. They said use cosine 4 as minus 0.7. Okay, and 11 sine 4, they said use sine 4 as minus 0.8. So 11 minus 0.8. If let's do this on our calculator. So minus 11 times minus 0.7 plus 11 times minus 0.8 plus 11, you get 9.9. How do I get 9.9? Give me a sec. Okay, but I'm taking a look now. This 11x, I forgot to take it down here. No, sorry. Where? Yeah, this is 11x. It's 11x times negative cosine x. So I forgot to put the x down. So sorry, negative. So it's going to be negative 11x, so negative 11 times 4. Okay? And over here, it should be negative 11 times 0. Okay? Just substituting it properly again. Okay? So this is going to be negative 11 times 4 times cosine 4, we said is negative 0.7. Plus 11 sine 4, so 11 times negative 0.8. And then since now we put in the negative 11 times 0, this cosine 0 is not going to be 11 anymore, it's going to be 0. Because negative 11 times 0 times cosine 0 is just 0. So this should give me 22. Yes, it gives me 22. Okay, very easy. Literally just product rule. Okay, question 2. What is the value of, from 0 to 1 over 3, 27x e to the 3x dx? Okay, once again, product rule, right? This is integral 27x times e to the 3x dx. Okay, from 0 to 1 over 3. So it's product rule. So we're going to use the rule again. Integral u dv is equal to uv minus integral v du. Okay, type. Let's choose our u and our dv, and then therefore we're going to get our du and we're going to get our v. So let's see. Which one here is easier for me to derive and which one is easier for me to integrate? Like I told you, anytime you see a linear function, 27x, 7x, 15x, I don't know, 24x, always choose that as your u. It's going to make your life very easy. Okay, and then e goes to e to the 3x. Thing is with e is both very easy to integrate and derive. But in this case, the easiest thing for me to derive, I'm just going to throw it here into 27x. Okay, type 27x will become what? 27. Then e to the 3x, what's the integral of e to the 3x? It's 1 over 3 e to the 3x. If you don't know, the rule for e to the power of u is equal to 1 over u prime e to the u. Okay? Integral. Okay, if you don't know. How, once again, how do we go from here to here? I told you, from dv to v, that means you integrate. From u to du, you derive. Okay? Anyways, so we now have our u, du, dv, and v value. So let's plug everything back in. So u times v, so u times v, so 27x times 1 over 3 e to the 3x plus minus, integral v now is what? 1 over 3 e to the 3x and then du is what? 27. And let's put a dx always. Always throw the dx back in. So we now have this. Obviously, we're not done. We need to simplify a bit. 27 and over 3, I'm just going to make it 9. So 9x e to the 3x minus. Now let's integrate this. This is at times. Okay, let's integrate this. 1 over 3 times 27. Again, I'm going to cancel it, make it 9. I'm going to take that 9 outside. Okay, so minus 9, and we're left with inside integral e to the 3x dx. Now again, how do you integrate e to the 3x? Like I told you, it's just going to be 1 over 3 e to the 3x. And then obviously we have, I'm not going to put plus c after we've done everything. I'm going to put the bounds because they said from 0 to 1 over 3. Okay, again, how am I doing this? It's just this rule. Okay, if you don't know how to integrate e at this stage, you really need to start rethinking your life, man. Maybe go to 11, maybe go to 12L. It's this rule, you need to know it. Okay, e to the 5x مثلا, the integral of it will be what? 1 over 5 e to the 5x. Okay, anyways, moving on. So like I showed you, it's just this table over here. Once you get this table, you just plug everything back in and you're done. Okay, I integrated, as you can see, let's simplify now. This 9 over 3 is just going to become 3, so it's going to be 9x e to the 3x minus 3 e to the 3x. Now we're going to do this from 0 until 1 over 3. Okay, so 9 times 1 over 3 e to the 3 times 1 over 3. I'm just substituting all the x's with the bounds, right? Minus 3e 3 times 1 over 3. Now, minus open brackets. This was me substituting 1 over 3. Now, let's substitute 0. 9 times 0 times e to the 3 times 0 minus 3e to the 0. Now, this here is going to get cancelled. This will not get cancelled. Remember, e to the power, anything to the power of 0 is 1, not 0. Okay, so let's simplify this. I'm going to go up. 9 over 3 is going to become 3. E, 3 times 1 over 3 becomes what? 1. So it becomes 3e to the power of 1. So 3e to the power of 1, I'm not going to write it. Minus 3, again here, 3 times 1 over 3 becomes 1. So minus 3e again. Okay, minus, open the brackets here, minus 3e to the power of 0. So what do you get? This cancels. Minus minus becomes plus 3e to the 0. And e to the 0 is just 1. So this is just equal to 3. Can you do all of this in your calculator? Of course you can. Okay, this is all solving on paper. What do you need to put in your calculator? This is what you put into your calculator. After you get this, after you're done integrating, خلاص, it's very easy to put in the calculator. You just put 9 times 1 over 3 e to the power of 3 times 1 over 3 minus 3e to 3 times 1 over 3 minus open bracket 9 times 0 times 3 e to the power of 3 times 0 minus 3e to the 0. Put this on a calculator, you're going to get 3. Okay, sometimes you can't do it on a calculator because they ask you e to the power of something. E to the power, let's say, I don't know, n. Okay, they tell you find n. But in this case, they just want the exact value, so you can throw it into your calculator. Again, nothing too hard. I think 10 minutes, 15 minutes. Okay. Some of them are annoying, but yalla, it's okay. The main idea is there. Oof, okay. Can I use Tabular? I think I need to use... 1 second. Okay, so over here, you have... Now, again, product rule. But this time, the first product is a bit longer. And you're going to see this if you're ever going to do maths in your life. You're going to see stuff like this. Integration by parts is very important. Extremely important if you want to do anything in your life that has to do with math. So over here, again, it's product rule. So we're going to reuse the same rule. Integral u dv equals uv minus integral v du. Now, you're going to see with this one, since it's a bit longer, you're going to have to do an extra step. And while solving, you're going to see. Okay, so over here, same thing. Let's call our u and dv and du and v. Okay, so let's see. Over here, like I told you, when you have e to the x, always throw it into the integration side. Okay, and whenever you have a linear function, something x, whatever, it's just linear, throw it into your u. So over here, we can say 3x squared plus 2x plus 1. طب يلا, what's the derivative of this 6x plus 2? What's the integral of e to the x? It's just e to the x, right? Okay, so let's apply our rule, uv minus integral v du. So uv, so 3x squared plus 2x plus 1 times e to the x minus integral v du e to the x times 6x plus 2, and always throw that dx. Now, someone's gonna come and say, oh, طب Walid, what do I do now? I need to integrate this. Now, as you can see here, this is another product, right? It's another product. You have something times something under the integral. So what do you do in this case? You need to do one more integration by parts. Okay, so let's do it again. We have to call our u and our dv one more time. Okay, let's do it. What's gonna be u, what's gonna be dv in this case? Like I told you, always choose the something times x, the functions with x, put them here, okay, on your u, because they're very easy to derive. Okay, and dv, we're just gonna put e to the x. Okay, let's see. So what's the derivative of 6x plus 2? It's gonna be just 6, and what's the integral of e to the x? It's just e to the x. So let's apply our rule one more time. uv minus integral v du. So uv, so 6x plus 2 times v, which is e to the x, minus integral v du. So e to the x times du, which is 6. So I'm just going to put 6e to the x dx. Now, can we simplify this? Yes, we can. 6x plus 2 into ex. We can do this integral. What's the integral of 6e to the x? It's just 6e to the x, right? Take the 6 out, and then you just have the integral e to the x, which is just e to the x. Okay, so we figured this part out, right? We then said we have to integrate this, and we found the integral of this to be this. Okay, so how are we going to write this now? It's going to be 3x squared plus 2x plus 1 e to the x minus, please don't forget this minus here, the integral of this, which we found as this, 6x plus 2 e to the x minus 6e to the x, and there you go. This is your integral. Now, what are they asking for? They're saying, what's the value of I of 1? So they want you to substitute 1 in this case. So substituting 1 into your x, you can do this, but I got this, okay? 10.87 to the nearest whole number, that's what? That's just 11, okay? So what's the extra step here? You had to do another by parts. You see, another one, okay? Now you're gonna see, maybe sometimes you're gonna have questions where you have to do 3 times, 4 times, and you're gonna keep on going, and sometimes you end up in a loop where you never end. And these are all integrals you might see, but for this level definitely you won't see it. But you know, I'm just telling you, that's whatever. Okay, خلاص, I'm gonna stop. Let me just chop and go next. Question 4. Okay, ln to x. Okay, integral of ln to x. Now this is a very famous integral. Someone's gonna come and ask me, okay, how do you do this? There's no product rule. How do you do integral of ln? Is there a rule I can memorize? Actually, there is a rule you can memorize, if I'm not wrong. But let's prove the rule together, because I forgot what the rule is. I think it's x ln x minus x. So I'm not sure. But let's see. Over here, ln to x. Now, for the integral of ln to x, mathematicians were kind of like, what do I do, For integral ln to x, there's nothing you're multiplying the ln by. There's nothing. This is when mathematicians came and said, okay, but this is the same thing as 1 times ln to x, right? dx. So we can easily just call our u as something and dv as something, and it's very easy. So let's call our u as, let's try, I'm gonna walk with you. Let's try calling our u as 1. Choosing 1 is gonna get you what? Whoa, I mixed these up, sorry. U, du should be under it. Choosing 1 as your u will give you, what's the derivative of 1 is 0, right? Okay, and that means we're gonna choose ln 2x as our dv, and therefore, how do you go from dv to v? You need to integrate. And نحن أصلا, do we know how to integrate ln 2x? No. So that means we're not allowed to choose 1 as u and ln 2x as dv. So we're gonna try now the other way around. To see how you can kind of tell from the start whether or not the combination you chose is the correct combination or not. Okay, so let's try now choosing ln 2x as my u and 1 as my dv. Now, what's the derivative of ln 2x? Remember, the derivative of ln u is equal to u prime over u, right? So the derivative of ln 2x is u prime, which is 2 over 2x, which is just 1 over x. Okay, now dv, to go from dv to v, we need to integrate. What's the integral of 1? Integral of 1 is just equal to x, right? So x. So now we know our table. Let's apply our rule. What's our product rule? Integration by parts. U dv is equal to uv minus integral v du. Perfect. Let's do it. uv, so ln to x times x. So x ln to x minus integral v du. So integral x du is 1 over x. X times 1 over x. Obviously, you have to put the dx under the integral, okay? So you're going to get x ln 2x minus x and 1 over x cancel, so you're just going to be left with 1. What's integral 1? It's just x. So x ln 2x minus x plus c, right? Very simple, very nice and easy. So you get this. Now, is there a rule you can memorize? If I'm not wrong, yeah, the integral of ln u is equal to integral of ln x, sorry. No, don't memorize it, you want just know it. Integral of ln x خلاص alone is equal to x ln x minus x plus c. Okay, this is a rule if you want to memorize. Here they said 2x, so you have to put instead 2x. Okay, don't memorize it, ahsan to solve it. It's not that hard. Well, it's really not that hard. You need to know how to use integration by parts. Okay, question 5. Over here, I can't really see. What's that? That's, well, I can't see. Hold up. Is that, what? Is that a 9? 9 over 8 over 2? Then they would just say 4, no? I honestly have no idea. I'm trying to, 5, maybe I think a 5 over 2. 1 over 2 to 5 over 2. Let's try, and we'll see, because I can't really see it. I hope it's a 5 over 2. Let's see. So integral x squared ln 2x. So over here, integral x squared ln 2x. So integral x squared ln 2x dx. Okay, so again, we need to choose our u and dv and our du and our v. So what is our u? What is our dv? Let's take a look. Now, we can choose u here as x squared, and we're going to make it 2x. Sorry, we can choose our u here as x squared. And then du would be 2x. And then dv, choosing, that means we're going to have to choose ln 2x as my dv. And then what's the integral of ln 2x? Again, we don't know it. Supposedly, we don't know it. Okay, we don't know it. So, you can substitute the rule, whatever, x ln 2x minus x as your v, but that's going to be way too long. So, in this case, it's easier for you to derive ln 2x than to integrate it, okay? So, always ask yourself, what's easier for me? Is it easier for me to put ln 2x here and x squared here? If I put x squared here and ln 2x here, I can't integrate ln 2x. It's hard. It takes time, okay? So, over here, we're going to do it like this. Which one's easier for me to integrate? Which one's easier for me to derive? Ask yourself that, okay? In this case here, the easiest one to integrate is x squared. So we put x squared there. Type. What's the derivative of ln 2x? We said it's 1 over x. How do you do it? It's u prime over u. So it's going to be 2 over 2x, which is just 1 over x. Okay. Now what's the integral of x squared? It's 1 over 3 x cubed, right? So we can say x cubed over 3. Okay, everyone knows how to integrate. So applying our rule, integral u dv equals uv minus integral v du. U times v will be x cubed over 3 times ln 2x minus integral v du, so x cubed over 3 times 1 over x dx. Now we can cancel this and this. It's going to become x squared over 3. Let's solve this down here. So it's integral x squared over 3 dx. How do you do it? It just becomes x cubed over 9, right? I think everyone knows how to integrate. You add 1 to the power and divide by the new power. Okay, so it becomes x cubed over 9. So taking this back up, this is going to be, let's carry everything down. X cubed over 3 times ln 2x minus the integral, we found it to be x cubed over 9. Okay, plus c. Okay, over here, we want to go from, how's there e? No way there's going to be e. Okay, I'm just going to continue solving. Okay, plus c. They wanted to go from 1 over 2 to, I think, 5 over 2. So we're going to remove the plus c. I don't care about the plus c since we have our bounds. We're going to go from 1 over 2 to 5 over 2. Let's take it down. Let's start with 5 over 2. So 5 over 2 cube over 3 times ln 2 times 5 over 2 minus x cube, again here, 5 over 2 cube over 9 minus open brackets, substituting 1 over 2. So 1 over 2 cube over 3 ln 2 times 1 over 2 minus 1 over 2 cube over 9. Now let's simplify this. I really have no idea how they got e in their answer. So let's see. Let's simplify this one by one. The first thing I'm going to do is ln 2 over here and 2, they cancel. So you're left with ln 1. And ln 1 is 0. So this cancels to get 0. This 2 and 2, we're going to cancel it. So it's going to become ln 5. So we're going to have 5 over 2 cube is 125 over 8 over 3 ln 5 minus, again, 125 over 8 over 9. Minus, over here this got 0, and we're going to get 1 over 2 cube is actually 1 over 8. This minus, I'm going to make it a plus. So this 1 over 2 cube, I'm going to make it 1 over 8 over 9. Okay, so we have a lot going on here, so let's kind of simplify this. 125 over 8 over 9. Remember, when we have denominator over denominator, we can just throw it down. Over 8 over 9, since we're throwing them together, 8 times 9 is 72. So I'm going to make this 125 over 72. This 8 over 9, again, I'm going to throw it together. I'm going to make it 72. So 1 over 72. So let's also do that over here. 8 over 3, we're going to make that 24. Okay, so we're going to get 124 ln 5 minus 125 over 72 plus 1 over 72 is going to be minus 124 over 72. Okay, so actually, we can do some things here. We can factor out the 124s. I really have no idea how they got 2e cubed plus 1. But let's take a look now. Okay, so after half an hour of staring at the screen, I just realized, no, look, the integration part, we did everything correct. But I realized this number here is e over 2. Now, my blind eyes can't see it, but now I just saw it. So this is e over 2, actually. Okay, so we got the substitution part here at the end, I got to redo it. Okay. I'm sorry for time wasting, but it's just substitution. We didn't. It's nothing. Substitution. Anybody can substitute. Okay, so let's substitute now properly. So e over 2. So this is gonna become e over 2 cube over 3 ln 2 times e over 2 minus e over 2 cube over 9 minus open bracket. Now substitute the 1 over 2. You're going to get 1 over 2 cube over 3 ln 2 times 1 over 2 minus 1 over 2 cube over 9. So again, like I said before, this one here cancels to get you 0. Why? Because 2 over 2 cancels. You're going to have ln 1, and ln 1 is 0. Okay, so this cancels, gets you 0. Type. Let's simplify here. E over 2 cube becomes e cube over 8 over 3, right? Because e cube is e cube, and then 2 cube is 8. Okay, ln 2 and 2 cancel, so you get ln e minus e cube over 8 again over 9. Okay, minus, this gets you 0. This minus becomes plus. Okay, and you're going to get 1 over 2 cube, which, like I said previously, is 1 over 8 over 9. Let's fix this up. So ln e is 1, by the way. Okay, so e cube over 8 over 3, denominator over denominator. I'm going to do this for all the denominators. Remember, we just mix them together. So you're going to get e cube over 24. I'm going to multiply them, huh? When you take it down, you multiply. Minus e cube over 72 plus 1 over 72. So our common denominator here is 72. So let's make it multiply by 3 here and here. Okay, you're going to get 3e cube minus e cube plus 1 over 72, which is 2e cube plus 1 over 72. Thank you so much. What should thank you? I have 5 questions left. Okay, sorry for the mishap. Okay, it's called a mishap when you make a mistake, right? Okay, whoa. Okay, let's ignore part B. Let's stay here. So what is ln for x? Again, you can just memorize the rule. It's just x ln ax minus x plus c. The integral of ln ax is equal to this all the time, okay? But again, let's solve it. It's very fast to do the integral of ln for x. You need to use by parts, okay? If it's written part and you just put the rule, of course, you're going to get it wrong, okay? So integral ln for x, how do you do it? Integral ln for x. We agreed that ln for x is 1 times ln for x, right? So we need to take u and we need to take dv, right? What is my u value? My u value, we can't choose 1. Remember, we can't choose 1. You have to take ln for x. Why can't we choose 1? Because if you choose 1 as u, your du will be 0. And that can't work. Okay, so we choose u as ln for x and dv as 1. The derivative of ln for x is 1 over x. Again, using what rule? The derivative of ln u is equal to u prime over u. What's u prime here? 4. What's u for x? 4 and 4 cancel, you get 1 over x. Okay, dv is 1, so the integral of 1 is just x. Okay, so now let's apply our rule. It's uv minus integral v du, right? So here, what's it going to be? Ln for x times x, so x ln for x minus integral v du, so x times du, which is 1 over x. Always please put the dx under your integral. X and x cancel, you're going to have 1, and integral 1 is just x. Okay, so you're going to have x ln for x over here, and this is minus x, and obviously plus c. Part B, integral e to the t sine 5t dt. So this is one of the harder ones. Let's write it here. E to the t sine 5t dt, of course. Integral. Type. We're going to choose something as u and something as r dv. What here is easier to integrate and what here is easier to derive? Like I told you, sorry, this becomes b. Like I told you, the one that's easier to derive and goes here, and the one that's easier to integrate goes here. What's easier to integrate? What's easier to derive? Now they're both يعني صراحة very easy, but I think e to the t. If you ever see e, put it in your dv. Okay, anything with e, put it as your variable to be integrated. It makes your life easier. Okay, so if we put e to the t here, u here will be sine 5t. Again, if you swap them, that's completely fine, but I'm telling you from my experience, putting e and the variable to be integrated is easier. Okay, sine 5t, what's the derivative of sine? It's cosine 5t, and remember, you have to multiply by the derivative of what's inside. Okay, if you remember, sine ax, the derivative of it is a cosine ax. You have to multiply by the derivative of what's inside. And cosine ax, what's the derivative? It's a negative sine ax. Okay, these two you should know them already from previous things. Okay, so what's the integral of e to the t? It's just e to the t, right? E to the x, integral of it is just e to the x. Okay, so we now have our u, v, dv, whatever. Let's start our integral. What is the rule? Integral u dv is equal to uv minus integral v du. طيب يلا. What's my u, what's my v? Sine 5t and e to the t. So sine 5t e to the t, I'm going to put this like this, minus integral v du. So v is e to the t, du is 5 cosine 5t. Now, this will be the first time you're going to see some sort of loop. Okay, so over here, do we finish? We have sine 5t, e to the t, and then integral e to the t, 5 cosine 5t. Are we done? No, we have to do another by parts. Why do we have to do another by parts? Because you have another product rule. So again, we need to take a u and we need to take a dv. Now, I'm going to tell you something, and it's a rule. Okay, if in your first by parts you took e to the t as your dv, that means here you're not allowed to change it. You have to continue with e to the t as your dv. Okay, so over here you have 5 cosine 5t. Okay, so you're not allowed to put e to the t now as my u. No, never. Okay, if you're continuing and you have to do another by parts, so you did by parts and you ended up with another integral that needs to be done by parts, you need to do the same u and dv. Okay, although now you have 5 cosine instead of sine, but my point is you can't have e to the t as your u now. Anyways, continuing on, what's the derivative of 5 cosine 5t? It's negative 25 sine 5t. Using this rule here. Pause and do it if you don't understand. Okay? Sorry, this rule here, not the one on top. Okay? dv, what's the integral of e to the t? Against e to the t. So now we did another by parts. So the integral of this, let's take it down. How do we do it? We have our table done. Again, just plug everything back in again. So uv, so 5 cosine 5t e to the t minus integral v du, so v e to the t times du, which is negative 25. I'm gonna see how it's, I'm gonna put negative 25, right? But to make everything cleaner, I'm gonna take the negative out and put it plus. Okay, because it was a minus here. If I take negative out, it's gonna be minus 1. So I'm just gonna put 25 sine 5t. The minus, I took it out and made it plus, okay? Just so my work looks a bit cleaner. Okay, so I think here you can kind of see that I have some sort of loop, right? So I started with e to the t sine 5t. And again now here, I have e to the t sine 5t. But if I just take this 25 out, okay, so let me just rewrite this as 5 cosine 5t e to the t plus, I'm going to take this 25 out, integral e to the t sine 5t dt. So as you can see here, we're back with what we started, right? We're back with exactly what we started. So what do you do in this case? It's very simple, okay? You write, what do we have? When you reach something that's your original integral, when you realize you're in a loop, you pause, okay? You stop there, you finish what you're integrating, you stop. We finished integrating, right? We got this, okay? And this is a continuation of this over here. So we have 5 sine 5t, let's write everything now. 5 sine 5t e to the t minus the integral here, which we found as this. 5 cosine 5t e to the t plus 25, put a bracket, 25 integral e to the t sine 5t dt. Okay, so we got this. Now we understand that this is all equal to what? What are we trying to find, aslan? Integral e to the t sine 5t dt. This is what we're trying to find from the start. So can't we kind of solve this as an equation? Yes, we can. What do you mean, Walid? Let me show you. Okay, let's distribute the minus here. Okay, let's distribute it. You're going to get integral e to the t sine 5t dt equals 5 sine 5t e to the t minus 5 cosine 5t e to the t minus 25 integral e to the t sine 5t dt. So I have integral e to the t sine 5t dt. And here I have minus 25 integral e to the t sine 5t dt. Can't I just move this to the left and add them together? It's going to become, on the left side now, I'm going to have what? Integral e to the t sine 5t dt plus 25 integral e to the t sine 5t dt. Right? Now, can't we just add these together and make it 26 e to the t sine 5t dt? Of course we can. So we're going to add these together. I want some space, so I'm just going to remove this arrow and continue down here. So it's going to be, taking this to the left, it's going to be integral e to the t sine 5t dt plus 25 integral e to the t sine 5t dt. Perfect. Now this is all equal to what? 5 sine 5t e to the t minus 5 cosine 5t e to the t. Okay, so what they did here is they factored out the e to the power of t. I'm going to do that later. What's my point here? We can simplify this and make it 26, as we said previously, right? Let's make this here 26. So over here, I'm going to continue. I'm going to get 26 e to the t. Sorry, it's going to become 26. I'm going to take this up, if that's fine. Okay, 26. I'll continue here. 26. This 1, you can say this is 1 integral e to the t. This is 25 integral e to the t. So it's going to become 26 integral e to the t sine 5t dt equals 5 sine 5t e to the t minus 5 cosine 5t e to the t. Now, we can factor out e to the t, right? I don't like when I have e and e together, so I'm going to factor it out. So we get 26 integral e to the t sine 5t dt equals equals e to the t out. I'm gonna have 5 sine 5t minus 5 cosine 5t e to the t out. Okay, now if we just divide by 26 on both sides, what's it going to look like after we now divide by 26 on both sides? It's going to be integral e to the t sine 5t dt equals 1 over 26 times 5 sine 5t minus 5 cosine 5t e to the t. And as you can see here, we figured out what our integral is. This is the integral we were starting with, and this is what we ended with. As you can see, we ended with what we wanted to find. And there you go. We solved it كأنه it's an equation. So over here, filling in the blanks is going to be 1 over 26. And over here, it's going to be sine 5t and minus 5 cosine 5t. It's kind of, let me take everything up. This is the answer here, right? So you substitute the 26, 5, 5, and 5. Now, is it long? Definitely. If I said it's not long, I would be lying to you. Would you see a question like this in your exam? Definitely not. But these are questions that I don't think it's going to come written now, but this is stuff you do in university, and it's not something you'd see in a school exam ever in your life. Okay? So I'm just going to move on, but this is just nice and to know how to integrate by parts. This is actually called a loop. What they do is they call this as I, and they ask you what is I equal to. Okay? Anyways, let's move on. Question 7. Okay, so this is continuing question 7. Integral from 0 to 1 over 4 of cosine inverse 2t dt. Okay, you need to know for this question that the derivative of cosine inverse is 1 over 1 root 1 minus x squared, okay? So, like I said, this is the same thing as integral ln x. Although there's nothing else there, you need to imagine the one that's beside it. Okay, so we're going to rewrite this as integral 1 times cosine inverse 2t dt. Just a disclaimer, this probably won't come, but I'm just solving it for the future, okay? Probably won't come. So doing this here, we need to choose our u and our dv. Now obviously we can't use 1 as our u, so we're going to choose cosine inverse 2t as our u and 1 here. Okay, so what's our du? What's the derivative of cosine inverse? It's 1 over root 1 minus 2t squared. Okay, now here's the thing. This is 1 minus x squared. Now if it was u, you have to multiply by u prime. Okay, so times u prime. What's the derivative of 2t? It's 2. Okay, so this is just going to be, we'll keep it like this. And dv, if dv is 1, that means v is going to be what? What's the integral of 1? In this case, it's usually x. Since we're working with t, I'm just going to say t. Okay. So we have our u, v, du, and our dv. So we can start solving. Let me just make this a bit neater. We said u is equal to cosine inverse 2t. So du is 1 over root 1 minus 2t squared, all squared, times u prime. What's u prime? Derivative of 2t, which is 2. Now we said dv is equal to 1, so v is equal to t. So let's now apply a rule. It's uv minus integral v du, right? So let's continue. uv, so t times cosine inverse 2t minus integral v du. So t du is, we're going to put it like this, 2 over 1 minus 4t squared, all under the root, and we're going to put dt. Now I'm just going to take this 2 outside here, so it looks like this. Now over here, we need to solve this. We're going to take this radical up. So it's going to be, I'm going to solve this integral alone. Let's take the radical up. It's going to be t into 1 minus 4t squared, the power of negative 1 over 2, right? dt. What do we do in this case? How do you solve this integral? You say u is equal to 1 minus 4t squared, right? So what's du? It's negative 8t dt, right? So to substitute dt, what will we do? dt is du by negative 8t. So we're going to go back here. It's going to be integral t u to the power of negative 1 over 2. dt became du over negative 8t. tu and t will cancel. Okay, so we're going to have, how do you solve this integral? It's going to be 1 over negative 8. Take that out. U to the negative 1 over 2, what do we do to it? We add 1 to the power, so it becomes 1 over 2, and we divide by the new power. So it's going to become negative 1 over 8 times, dividing by, like, u over 1 over 2, fraction over fraction, we're going to take the 2 up, right? So it's going to be 2u 1 over 2. So we're going to cancel this 2 and this. So it's going to be negative 1 over 4 u to the radical u, because about 1 over 2 means radical. Okay, so that means, what do we say u is? 1 minus 40 squared. So it's negative radical 1 minus 40 squared over 4. So this is this integral here. So that means this is all equal to, let's plug this back in as our integral. So t cosine inverse 2t minus 2 into minus minus, we're just going to make it plus. So plus 2 root 1 minus 40 squared over 4. This is your integral. Let's cancel this and this, make it 2. Okay, so this is your integral now. We need it from 0 to 1 over 4. So let's substitute from 0 to 1 over 4. Substituting 1 over 4, I'll do it here. You're going to get 1 over 4 cosine inverse 2 times 1 over 4 plus root 1 minus 4 into 1 over 4 squared all over 2. Minus, substituting 0, you're going to get 0 here, plus root 1 minus 0 over 2. Let's do it. You're going to get, I think they want you to do it step by step, as you can see here. But let's do it step by step, like one by one. 1 over 4 cosine inverse 2 times 1 over 4. Let's do that. 1 over 4 cosine inverse. By the way, you need to be in radians if you want to work with cosine inverse. 2 times 1 over 4. You're going to get pi over 12. So this first one here, we're going to get pi over 12. Type here, what's that going to be? How do they get negative? I don't know how they got negative. I'm just going to continue. So we're going to do now this one here. Root 1 minus 4, whatever. It's fraction. Root 1 minus 4 times 1 over 4 squared over 2. You get root 3 over 4. And then the half, this is just half if you do it. Okay, so plus 1 over 2. Now, I don't know how they got the negative here. Maybe I made a mistake somewhere. If I did, please let me know. But I don't see where I made the mistake. Okay, so I just checked. And actually, the mistake is that the rule for cosine inverse is it's negative. So over here, that means du should be negative. That means, where did I continue? Yeah, over here, this should have been negative. Okay, well, that means the negative should make this plus. So that means when I substitute the negative back in, it doesn't make it plus, it should be minus. Okay, so that means here it's a minus. So over here, this is a minus. Very easy, not hard. But it's just, I don't think this is not gonna come. It's not gonna come, okay? Question 8, tabular integration, I'm gonna skip it. Okay, it's just by parts, it's not gonna come. I'm telling you it won't come. Okay, tabular integration means it's by parts. So you do it by parts the first time, and then by parts the second time. Maybe you have to do it the third time. It's just very long. It's very unnecessary. Okay, question 9. Evaluate the definite integral of x cosine x or x sine x using integration by parts. Okay, this is very easy. We'll do this. So 24t cosine 2t, as you can see here, it's a product. So we're going to do our u and dv, right? What's my u? Always, if you have a linear function and a trigonometric, always the linear function, you're definitely going to see a question like this. You will definitely. 24t, I'm going to take it as my u. Always take your linear one as your u. Okay, so what's du going to be? 24. Type dv is what? It's cosine 2t. So v is going to be integral of cosine, which is sine 2t over 2. So remember, for trigonometric functions, you have to divide by u prime if you're integrating. Okay, المهم, so we got this. Now applying our rule, uv minus integral v du, we get what? uv, so 24t, times sine 2t over 2 minus integral v du, so sine 2t over 2 times 24. So we're gonna put dt here, right? Let's put some cancelling. So 12t sine 2t minus integral 12 sine 2t dt. Now, how do we integrate this? Very easy. We know that the integral of sine is negative cosine. So minus negative cosine 2t. Let's just keep this 12 here. Over 2. Remember, you have to divide by u prime. Okay, and then plus c. Now, we would usually put plus c, but here we have our bounds. We're actually going from 0 to pi over 4. So I'm just going to put this all from 0 to pi over 4. Okay, so this minus minus becomes plus, and this 12 and 2 cancels. So you have 12t sine 2t plus 6 cosine 2t from 0 till pi over 4. Okay, so 12 sine 2 times pi over 4 plus 6 cosine 2 times pi over 4 minus open bracket 12t sine 2 times 0 plus 6 cosine 2 times 0. Okay, so I'm gonna tell you this gets you 0. Okay, do it on your calculator, do it one by one. Okay, because since they wanted piece by piece, this will get you 0. This here will get you 12. Okay, this here will get you 0, and then this here will get you 6. Okay, I don't know how they got the pi now. 2 times 0, 2 times, hold up. Once again, I have done it again. I forgot to take the t down. The t, see, 12t sine 2t, 12t sine 2t, 12t sine 2t, and then here I forgot, I completely forgot it. Okay, so I forgot the t. Okay, so I should also substitute the pi over 4 here. So it should be pi over 4 times this, and then here pi over 4 times this. Also it's 0, so it doesn't matter. Okay, so over here pi over 4, here you're gonna get 12. Okay, now pi over 4 times 12 is 3 pi. Just do this on your calculator, you're gonna get 3 pi. Okay, then here we said this is 0 and this is 0. Okay, and then minus 6 cosine 2 times 0 is 6. So 3 pi minus 6. This is your answer. Okay, very easy. Question 10. Okay, you have again tabular integration. I'm gonna give you the rule for tabular integration, and I'm just gonna solve this one question, and it's very long, so it won't come, but I'm just gonna give you the rule. I'm not even gonna solve. So tabular integration is just another form of by parts, but you need to go an extra step. Okay, so ideally you'd want to choose your f and your g. Okay, now here's the thing. G, we're gonna call it the next thing g and the next thing g hat. Okay, or you know what, actually we're just gonna call it dg, then g hat. Okay, then f, we're gonna call it f prime, and then f double prime. So you see how usually we just go one step, right? But here, no, بالعكس, we're gonna go an extra step. Okay, so we're doing two steps instead of one step. So this is when you have tabular integration. Someone might tell me, how do I know if I have tabular integration? That's the thing, you can't really tell. Okay, so usually what you do is you try by parts. If by parts doesn't work, you do tabular. Okay, when do you see tabular? If it's a polynomial. Okay, that's when you use it in math. If not, you just use by parts. So here, if you use by parts, it will work, but it's going to take you a bit of extra time. So mathematicians were like, you know what, we're just going to make a stupid thing called tabular integration, and you can use it with these polynomials. It saves you a lot of time. It's just one big formula. So if I'm not wrong, it goes like this. Wait, you need your sign, also your sign. So it starts positive, then negative, then positive, then negative. How you do it is you start like this. So you multiply this by this, then this, and this, then you go across up. 1 second, let me just double check. Yeah, I had to check it. Organic chemistry tutor, by the way. If you want to watch him, explains it in detail, and if you really want to, but this will not come. Okay, so this is how it works. It starts positive, negative, positive, but sometimes you can keep on deriving, and the polynomial can keep on getting derived, and derived, and derived, and derived. So that's why this actually continues for as long as you want. You know what I mean? So this is usually when you have huge equations, and at this school level you will never work with anything like this. Okay, يعني the school teaches you it, but I don't know why really. Okay, so in this case here we need to choose our f and our g. Now which one's easier to derive? Honestly, the easiest thing to derive here is x cubed, and if you choose cosine as your derivative, it will never end, because your cosine can keep on deriving and deriving, deriving. You're never gonna end. But x cube, at some point, you're gonna get to the point where you can't derive it anymore, because x cube will become x squared, and then x squared will become x, and then x will become 1, then 1 خلاص, at that point you can't derive anymore. So let's choose here our f and our dg. Our f in this case, I'm gonna take it as x cube, and my dg, I'm gonna take it as cosine 2x. Now let's go next. F prime is gonna be 3x squared. My g will be negative sine 2x, negative 2 sine 2x, sorry. Okay, my f double prime will be 6x. My g hat will be what? Will be negative, will be, derivative of sine is cosine, so it's gonna be negative 4 cosine 2x. Okay, now my f triple prime will be 6, and then my g double hat will be 8 sine 2x. Now we go plus, minus, and we cross. We go down like this. Okay? Type. And the next triple hat, if I'm not wrong, is negative 16 sine 2x. Cosine. 16 cos 2x. So you keep on going until you're done. Okay, now this is correct, but I just realized I was deriving instead of integrating. So my fault. I should integrate. Integral of cosine 2x is sine 2x over 2. Integral of that is negative cosine 2x over 4. Integral of that is negative sine 2x over 8. Integral of that is cosine 2x over 16. Okay, so now we set everything up. It's time for us to multiply. So it's gonna be, you just cross them, no? Wait. Yeah, all you do now is just cross. Once you set up your table with your signs, خلاص you cross. So it's gonna be x cubed times sine 2x over 2. So x cubed sine 2x over 2. Then minus 3x squared times minus cosine 2x. So it becomes plus, right? So cosine 2x over 4. Then plus negative sine 2x over 8. So we're gonna make it negative. You have to cross 6x and negative sine x over 2, 8. So 6x sine 2x over 8. Then minus again 6 times cosine 2x over 16. I'm just crossing. The table is the hard part, but after you cross, there you go. After you have the table cross, you just cross stuff. Okay, so what do? They simplified the two x's and together. So x cubed sine 2x over 2 and 6x sine 2x over 8. So actually I'm going to simplify this 6 and 8. I'm going to make it 4 and 3, right? And then I'm going to make this here. We can simplify the sine 2x's together. Okay, you have x cubed sine 2x over 2. So we can just make it 1 over 2 x cubed sine 2x. Let me take it down here. 1 over 2 x cubed sine 2x, right? And this is here minus 1 over 4 into 3x sine 2x, right? 3x sine 2x, and we have the 1 over 4 outside. Then here the rest you have plus 3x squared cosine 2x over 4. This 6 and 16, we're gonna make it 3 and 8. Okay, minus 3 over 8 cosine 2x. So we can simplify the cosine 2x and cosine 2x and the sine 2x, sine 2x. Now this here, if I factor out sine 2x, and I make the common denominator, this is going to become 2x cubed over 4, right? So let's factor out the 1 over 4 and the 1 over 4. 1 over 4 and the sine 2x. You have sine 2x in common and 1 over 4 in common. So we're going to take out 1 over 4 and the sine 2x. You're left with 2x cubed minus 3x. Okay, and then over here, taking the 3 over 8 in common, that means you're going to have to multiply by 2 up and down. So you're going to get 3 over 8 into 2x squared cosine 2x. You know what I mean? Minus 3 over 8 cosine 2x. Okay? Sorry, that we took the 3 over 8 out. Okay? And then now taking the cosine 2x out of this, we're going to have now in total 2x cubed minus 3x sine 2x plus 3 over 8 into 2x squared. And taking cosine 2x, nothing is going to be left, it's just going to be 1. You have cosine 2x inside here. So as you can see here, this is tabular integration. You use this when you have something that when you derive or integrate, it's not sufficient enough to do by parts. Okay, so this is when you use tabular integration. Thank you so much for watching, and good luck in your exam.